In this video we will have a look at how to paint live into a particle playground system. And to do that we will need a particle system. So I just created one through the playground wizard here found by the window menu particle playground, new particle playground system. And we will need a little script, nothing too advanced, but you will have to have some sort of basic knowledge of how to script in Unity to do this. We could call this script paint at raycast position. And this is a C# script. First off, we need to specify that we are using the particle playground namespace to be able to call functions and variables inside the particle playground framework. And we could start off by caching a reference to our particle system. And I was thinking we should just be able to drag this script onto the particle playground system we wish to paint into. So let's get the component here in the start function like that, and then we could cache the reference to the main camera as well, just for optimization reasons, so we don't have to use component lookups every time we want to do a paint. And to be able to paint, we would need some sort of logic that says when, for example, we press the left mouse button, we want to do a ray cast into the scene, and from that ray cast use the position and the other information available in the raycast hit to pass that into the paint function. So let's have a look at how we could do that. So let's just specify here that if the left mouse button is pressed, get mouse button down 0 means by default the left mouse button. Then we want to call a function, so let's create that. Let's call it paint raycast. And let's call that when we press the left mouse button. And we could use the ray overload for physics raycasting. So we can create a ray from the cached camera, main camera here. So ray equals cam dot screen point to ray, which requires a position. We could use the mouse position here, and then we would need a raycast hit as well. And let's call physics.raycast and the overload where you can pass in a ray and the hit info there, and specify out. All right. So when this raycast is shot into the scene, we will use the hit info here to paint into our particle system. So to do that, there's this wrapper function in the playground manager. So let's call that playground C, which is the playground manager, paint. And the paint function has two overloads, one that is expecting a playground particle C component, and one that is expecting a paint object C. And we could use our this first overload with our particles here. So let's pass in our particles, and the paint function here also wants a position, where the paint actually should end up. So let's use our hit point there, which is the hit position in world space. And it would also want a normal, and the normal is used for the local initial velocity to know which direction the local velocity should be calculated from. So let's use the hit normal there. And it also wants a transform, so we could use the hit transform. And then it wants a color, so let's just specify a white color there. And that is actually what should be sufficient enough to do a paint live into the particle system. And let's drag this script into the scene onto the particle playground system and set the source mode to paint. We could add some more particles here as well before we start. So from 100 to 1000. And we would need some sort of collider as well to be able to paint into the scene. So let's create this sort of cube to just try things out. And let's press play and see what happens. So now when we paint into the, or press the left mouse button, a raycast will be shot into the scene. And when it hits a collider, it will create a paint position. And we specified the paint parent here as our hit transform, and this enables us to follow the painted position here when the transform is moving and rotating. So this could be used to sort of, I don't know, if you want to have bullet holes in or create bullet holes in a sort of water tank or something. Just to show you what I meant by the local initial velocity there, let's have a look at the initial velocity here in forces and set everything here to 1. It will use the normal here to for its direction. So if we were to, for example, rotate, or actually we could do this. Let's create a sphere and put that in 0 position. Just scale that up. And when we paint onto this sphere, you can see that it sort of has this initial velocity based on the actual surface of the sphere. We could amp the force up a bit here as well. Or we could do it like this, which might be better. And there you go. So if your transform is moving, you could make use of the delta movement here to simulate kind of this sort of slingshot effect to this as well. So that's how you paint live into the scene onto colliders. Thanks a lot for watching.